Thank you, Edward. So in today's first sections, I'm excited to share our Smart Cockpit Scorecard, our first ever comprehensive benchmarking of 20 leading global OEMs. We will look into their progress in cockpit technologies and innovation, as well as their market and business performance. The scorecard results provide a snapshot of the relative positionings of the 20 OEMs, classifying them as leader, strong, contenders, and followers. As the auto industry moves towards intelligence, collected, and software-defined vehicles, the smart cockpit is becoming more important than ever. It plays a key role in shaping the user experience, improving how the vehicle works, and help brands stand out from the competition. In our smart cockpit scorecard, we rank OEMs based on how far they are advanced in the key smart cockpit technology. The goals of this effort is really to spotlight some of the industry leaders, those setting the pace in smart cockpit innovations. It also helps both OEMs and suppliers to understand where they stand so they can position themselves strategically and build innovation leaderships. At the same time, the scorecard also highlights new trends shaping the future cockpits and point out the gaps that OEMs need to close to stay ahead in a fast-moving market. In terms of methodology, the ranking is based on three main categories, each given equal weight. These include market and business strategy, future readiness, and how each OEM performs across the three core areas of cockpit innovations, including the immersive experience, intelligent system, and integrated technologies. In the scoring model, each category is assessed on a scale or level ranging from 1 to 5. To measure the cockpit intelligence, we follow the classifications from the China SAE white paper. It outlines 5 levels based on how well and advanced the system handle the 3 main areas, including the human-computer interactions, collectivities, and scenario adaptability. Let's start with a quick look at the result across the 3 key pillars of cockpit innovation and technology. The scores showed in the graph reflect how innovative and intelligence of each OEMs in terms of key technology in these immersive areas. To assess immersive experience, we look at 5 main areas: the interface designs, interactions modalities, AR, VR, personalizations, and ease of use. Displays are a big part of that, from central and panoramic screen to head-up displays and even holographic windows. Stacy will dive deeper into the display trends in our next sections. For interactions modalities, it includes touch, voice, and gesture control. And AR and VR are used nowadays in enhancing navigation and situations awareness, and also support design and development process. Personalization is important to allow cockpit to adapt to each user, and while ease of control ensure everything feels intuitive and keeps the driver from distractions. By evaluating of all these components, we calculate an overall immersive score of each OEMs. When we talk about cockpit intelligence, there are three key technologies: AI, context awareness, and data analytics. AI power smart features like voice assistant and predictive system. Context awareness use sensor to monitor inside the car and adjust setting for comfort and safety. Data analytics gather data and analyzing information to make system smarter and more responsive over time. In the integration area, we are looking at how well different systems inside the vehicle work together as one seamless experience. This includes software and ADAS integration. There are computer platforms manage and process the vehicle data, digital ecosystem integrations which connect car to the outside world, from IoT device to streaming service and more. The overall ranking is based on, we have mentioned before, the three main categories: the cockpit innovation and technology, the future readiness, and market and business strategies. As we go through the findings, I will highlight some key difference between OEM groups, spotlight a few trends that really stand out in today's fast-changing landscape. First, the leader. The scorecard highlights 5 leading OEMs. What set them apart is their ability to integrate in-car intelligence using their own operating system and centralized or zonal architecture. They are extending the limit with AI-driven system that deliver seamless user experience and personalized service. By fine-tuning hardware and software, they are able to scale quickly and efficiently, giving them a major competitive edge. It's also worth noting 4 out of the top 5 leaders are Chinese automakers, showing just how strongly China is shaping the future of smart cockpit innovation nowadays. Let's talk about what set Tesla apart. Tesla's biggest strength is its future readiness by fully integrate hardware, software, and AI. Its in-house operating system delivers strong performance through tight control through a closed ecosystem. But at the same time, the closed ecosystem lacks support for third-party apps, which could also limit flexibility. Tesla is ahead in AI and data. It is one of the few automakers with its own supercomputer powering real-time AI learning and features updates. In 2023, Tesla shipped to a fully neural network-based system with hardware 4 and rolled out the latest FSD, an end-to-end AI approach that truly set it apart from other competitors. And now we are seeing Chinese OEMs start to follow. But Tesla's success in autonomy really depends on how it navigates the global regulations in the future. In terms of challenge that Tesla faces is staying profitable. With ongoing price cuts in the market, it must continue optimizing costs while investing more in new technology to in order to stay ahead of these moving competitions, especially from China. Following Tesla, Chinese OEMs Li Auto stand out for its strength mainly in the hardware and software integrations. It delivers a deeply immersive in-car experience combining seamless spatial 3D interaction with advanced AI. On the immersive front, Li Auto is upgrading its infotainment system using Qualcomm Snapdragon Elite platform to, to bring next level performance and user experience. For AI, the company recently presented at the NVIDIA GTC event, unveiling a new autonomous driving architecture called MindVLA, a dual system architecture integrating end-to-end learning and vision language models. This model can translate visions and language into vehicle actions. It's really unlocking new ways for drivers to interact with the car. The company has a very strong presence in China, and now it faces exciting growing opportunities, but it all depends on how it tackles the challenge of global expansions, brand building, and sustainability. To strengthen its ecosystem and support broader collaborations, Li Auto also made a bold move recently by open sourcing its Halo OS. Next up is Geely Auto, a company making impressive progress in the smart cockpit space. Geely is combining the Qualcomm platform with also its own chip, showing its strong commitment to really build its hardware capabilities in-house. Geely's standout strength is really the Flyme Auto system, so including the Flyme Link connectivity platform, which is developed by Meizu. Meizu is owned by Geely too. And one area for Geely still need to catch up is the AI, because when compared to other Chinese OEMs which have invest heavily in AI-powered cockpit system, Geely is starting to scale up in this space too. Next is NIO. The major strength of NIO is really the Sky OS platforms. It is a platform built specifically for AI-powered software-defined vehicles. Sky OS is built on centralized domain control with a high performance and scalable architecture. NIO's AI ecosystem is also expanding. It includes Normie GPT, an intelligent assistant, and New World Model, the NWM. NIO is clearly a front runner in the SDV and also in terms of the AI intelligent vehicle technology. But its future success will really depend on how well it handles growing cost pressures, the rising competitions, and the challenge of turning innovation into sustained revenue growth. Next is Expand, also a Chinese OEM. Expand share many similarity with NIO. is strong in combining its own hardware and software, and also advanced AI models and highly customized driving experience. What difference expand focus is on the partnerships, collaborating with Alibaba Cloud and Volkswagen puts it a good position to continue innovating and scale more efficiently. But at the same time, Expand has the same weakness, same as Neo. To stay competitive, it really need to diversify its revenue streams and strengthen its long-term profitability strategy. To conclude, the leader groups is obvious. Chinese OEMs are leading in the cockpit innovations. For them to stay ahead, this company must continue to strengthen their global strategies and business foundations. That means improving scalability, boosting cost efficiency, and finding way to monetize cockpit features effectively. Tesla is still lead in software and cockpit integrations, but growing pressure from Chinese competitors, especially in pricing and market share. Chinese OEMs are heavily investing in intelligent systems. We are seeing advanced AI models, centralized architectures, and powerful data-driven platforms. When it comes to integration, the gap is closing fast. Chinese players are catching up in software, hardware, and also ecosystem coordinations. On the hardware side, there is a strong push towards full chip localization with a goal of using 100% domestic chips by 2026. Ecosystem development is also maturing. Many Chinese OEMs cockpit platforms are already tailored to local customer needs. And now the focus is on scaling those solutions globally. Now let's talk about the strong contenders groups, including 6 OEMs, and they are actively reimagining the technology stack to stay competitive. Especially, they are putting a strong focus on computing platform and operating system to support seamless over-the-air updates and deliver more personalized in-car experience. They just to highlight some of the key developments recently of these OEMs. For BYD, it's developing its own pilot system with chips from different tech providers. A major leap forward will come with its upcoming 20 architecture powered by NVIDIA DriveForce, which will enable seamless integration between the cockpit and the driving system. For Rivians, who takes a different path, Rivians building around the Snapdragons and NVIDIA chips is also adopt a Suno architecture, putting down the number of ECU as in-house software based on Android Automotive OS support regular updates and a user-first interface. Mercedes-Benz is launching its third-generation infotainment system and preparing its own operating system, a new chip-to-cloud system that brings AI-driven graphics, virtual assistant, and smart ADAS features to the next generation vehicle. And BMW is enhancing its iDrive system with next generation hardware and cloud-based features to deliver a more responsive digital experience. For Motor is also a Chinese OEM is integrating the cabin and driving system using its own OS system, the Snapdragon chips, and the unique architecture focusing on scalabilities and advanced driving assistance. In the rising role of cloud connectivity and ecosystem expansions, OEMs in these groups are rapidly advancing in this space by forming strategic partnerships with top tech players like NVIDIA, Google, and AWS, which enable them to have a faster development of cloud-based capabilities. Through these partnerships, helping OEM to unlock capabilities in real-time software updates, new features for the next level infotainment system, and deeper integrations of ADAS and AI functions. It's all part of a broader push to create more intelligent, connected, and seamless vehicle ecosystem. To summarize, the strong contenders group is investing heavily in software and strategic partnerships to transform the in-vehicle experience. Many of them are just now launching their own operating system as they work to gain more control over the software stack. Rather than going fully in-house, they are teaming up with tech leaders to fast track progress in the areas like AI, connectivities, and autonomous driving, focusing on speed to market. They are also modernizing vehicle architectures, shifting towards central and zonal architectures, setups to support over-the-air updates and reduce complexity. When it's come to user experience, they are catching up, adding AI assistance, immersive interface, and cloud collector service that enhance digital journey. Still, there are several challenges, including scaling up productions and improving operation efficiency, mainly are the major hurdles, especially for newcomers like Leap Motor and Rivian. For the next group, the contenders group, in this group, OEMs are also actively working to advance smart cockpit technologies. Same as previous group, they are putting a strong focus on their own OS platform, building AI capabilities and forming strategic partnership to stay competitive. However, despite these efforts, they still rank behind the industry leaders. And why? Because they face ongoing challenges with market performance and scaling their solutions effectively and being fully prepared for the shift towards software-defined vehicles. So just to highlight the key characteristic of this group of contenders mainly start later in the development of their own software and now are investing in their own operating system to gain control over the full tech stack and support over-the-air updates. To move fast, they relied on strategic partnership, working with tech the company to accelerate progress in AI, cloud connectivities, and cockpit innovation. But still, execution and scalability remains the major hurdles in this group. They face delays, roadblocks from software setback to organizational change and production scale issue, and also a slower software-defined vehicle rollout. And each brand can bring its own strength really to help them to compete. For example, for Volkswagen's global footprint, Toyota reliabilities, Lucid premium user experience, and GM's ADAS leadership. But truly compete, they will need to overcome both internal and market-facing challenge. The last group for the follower group, these OEMs have made progress in developing smart cockpit technology. However, each of them face unique challenges, whether it's advancing the technology and shaping an effective market strategies or executing operations efficiently. Together, these hurdles are limiting the ability to compete at the same level as the front runners in this rapidly evolving landscape. The key highlights for these groups, OEMs are making progress in smart cockpit innovations, but they still lag behind in terms of the software scale and overall executions. They have introduced some notable features like Android Automotive OS integrations, the advancement in infotainment system. But the core issue is really the limit ownership of their software stack, means they will struggle to differentiate and evoke the cockpit experience at the same pace as leader. And execution and scalability challenge also including the delays, setbacks, and fragment in rollout strategy are making it tough to deploy technology consistently across markets and models. And finally, the gaps in strategic alignment and holding them back, inconsistent investment in software platforms, user experience design, and integration has kept them step behind from the software-first competitor. At the end, to summarize the findings of our Smart Cockpit Scorecard, the integration is what set the leaders apart, combining hardware, software, connectivity into one seamless, user-friendly experience. And everyone is shifting to software-defined vehicle, but some are moving faster than others. And AI and data are really driving the future. Top OEMs are using AI for personalization and smarter features. Partnerships are speeding things up, especially with tech giants like NVIDIA, Google's, and AWS. But too much reliance on third party can limit how much controls an OEMs has on the overall user experience. The local strategy really matter. Chinese brands are excelling at home but facing challenge globally, and traditional OEMs are working to catch up with more innovation and better executions. So looking ahead, the industry will need more insight and accurate information to really help them to identify what really matters in terms of differentiating themselves from the other competitors. So thank you for joining today's sections, and if you have any questions, feel free to.
Thank you, Elaine. Can you talk a bit about looking specifically the lower ranked OEMs? What are the most common challenges that they're facing as far as achieving future readiness, both in terms of software and hardware roadmaps?
Yeah, thank you. So for lower end OEMs, they are facing a mix of challenges, including the structural, technical, and strategic challenges when trying to future-proof their hardware and software roadmap. I would say the major challenge currently is the core competency, the lack of skills and talent base, particularly in software, AI expertise, and the chip technologies. Also, the transparency and flexibility has really slowed down these OEMs in terms of SDV transitions and having agile platform development and adoptions of new technologies and innovations. So to really moving forward, I think for those OEMs, they can really leverage what they are strong originally. For example, in the ADAS and AD area, they should push for industry standard in those areas, aligned on really develop the standard and open source code for non-differentiating elements to help them to speed up the development, and also simplifying the architecture, especially adopting Suno domain control will really help them to reduce not only the cost, but also the efficiency of the deployments of new technologies.
Excellent. And one more question from the audience here. Which OEMs are leveraging partnerships versus developing in-house capabilities? Who's leveraging outside software development services, and what regions are benefiting from this?
So in the scorecard, we have talked about especially the container and strong containers group. So which includes mainly the legacy OEMs. They are really trying to leveraging partnerships, especially working with the tech companies, the Google's AWS, to really speed up. So especially in the areas of AI, cloud-based service, collectivities, and also the ADAS, the data, advancing the ADAS capabilities.
Excellent. Well, Elaine, thank you very much for that presentation. Really interesting stuff.